Hello and most welcome to 2063 of the series. We have the great pleasure today to start with a brand new article by Michael Esfeld, Quantum Entanglement and a Metaphysics of Relations. This, for me, was a condensation of what we went before about quantum relation or relational quantum mechanics. And it brings in strains about non-separability, entanglement, the interconnectedness, and actually also the monads. Yes, the monads are making a comeback. And I think that's a bit of a nice happenstance. I just got this newly published book. I don't know if it's visible. It's called Leibnizing. Oh God, can't see it.
No, we cannot see it.
I will stop blurring.
Try again. Try
There
again.
we go.
Now it seems it's
Richard Halpern
Richard
Leibniz,
Halpen. Richard Halpen. Okay, great.
a philosopher in motion. And as you might remember, it could be a clue here. Leibniz did not accept the idea of identity in the smallest things, the atoms, or what he called the monads. The monads have no windows, so you cannot look into them to see it is this monad. It has this individual property. As you will see here, it is rather in the lead of properties that are individual, are actually stemming from a global take, from everything. What Carlo Rovelli, for instance, called relational quantum mechanics, RQM. I can recommend as a complementary readings some of his books. But I will go into the paper here. I will stop my video and start the reading. We will end with a discussion as usual. Abstract. This paper argues for a metaphysics of relations based on a characterization of quantum entanglement in terms of non-separability, thereby regarding entanglement as a sort of holism. Holism! By contrast to a radical metaphysics of relations, the position set out in this paper recognizes things that stand in the relations, but claims that as far as the relations are concerned, there's no need for these things to have qualitative intrinsic properties underlying the relations. This position thus opposes, and listen now, a metaphysics of individual things that are characterized by intrinsic properties. A principal problem of the latter position is that it seems that we cannot gain any knowledge of these properties insofar as they are intrinsic. Against this background, The rationale behind a metaphysics of relations is to avoid a gap between epistemology and metaphysics. Metaphysics.
Metaphysics.
And this abstract sums it up pretty well. Introduction. The aim of this paper is to propose a philosophical characterization of quantum entanglement within a broader metaphysical framework. The framework is the one of a metaphysics of relations, in contrast to a metaphysics of individual things that are characterized by intrinsic properties. Intrinsic properties. A metaphysics of relations is a minority view in contemporary philosophy. For you to know. According to the mainstream of metaphysical thought, the world consists of independent individual things that are embedded in space-time. Listen up now, it's a good description. These things are individuals, because A, excuse me, got another visitor here. They have a spatiotemporal location. A spatiotemporal location. B, they are a subject of predication of properties each. And C, there are some qualitative properties by means of which each of these things is distinguished from all other ones. At least the spatiotemporal location is such a property. Welcome, Mirja. Nice to see you. Qualitative properties are all and only those properties whose instantiation does not depend on the existence of any particular individual. Properties such as being that individual are hence excluded. Are hence excluded. These things are independent because their basic properties are intrinsic ones. Intrinsic to the core, atomistic. Basic properties are fundamental in that they are not reducible to other properties, and they are not disjunctive. That is to say, properties such as being round or square are excluded. Excluded. Indeed.
Excluded.
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 Yes, Mia. Intrinsic are all and only those qualitative properties that a thing has, irrespective of whether or not there are other contingent things. All other qualitative properties are extrinsic or relational. Very important. That is to say, having or lacking an intrinsic property is independent of accompaniment or loneliness. I'm so lonely, oh no. And metaphysics of this type can be traced back to Aristotle, at least. Aristotle assumes that there is a plurality of things, substances, that are characterized by intrinsic properties, forms, each. A prominent contemporary conception is David Lewis's thesis of Humean supervenience. Humean supervenience. That's the first time.
Supervenience.
Supervenience. Humean supervenience. At the basic level of the world, there are only local qualities in the sense of intrinsic properties instantiated by space-time points or point-sized particles or field sources at space-time points. Space-time points. Space-time points can qualify as individual things in the above-mentioned sense. Everything there is in a world like ours supervenes on the distribution of basic intrinsic properties over all space-time points. All space-time points.
Points. Points.
All over points. Whether really everything supervenes on that distribution is not relevant to the present paper. What is important here is the claim that, except for spatiotemporal relations, all the relations between the things at the basic level supervene on their intrinsic properties.
Properties. Yummy, yummy.
Properties of their intrinsic properties.
Yummy, 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 yummy.
It's well known that quantum physics, notably quantum entanglement, poses a challenge to Lewis's Humean supervenience. This paper argues that quantum physics can be taken to suggest replacing a metaphysics of intrinsic properties with a metaphysics of relations. Once more, the final or the pertinent message is repeated, reiterated. A metaphysics of relations. Relations. This is, of course, a matter of weighing arguments in the interpretation of a physical theory. There is no direct route of logical implication from physics to a particular metaphysics. A metaphysics of relations is often dismissed out of hand, for it seems to be paradoxical. It seems that A, relations require relata. That is, things which stand in the relations, and that B, these things have to be something in themselves, that is, must have intrinsic properties over and above the relations in which they stand.
Stand.
Stand, stand. However, a metaphysics of relations merely has to reject the second part of this claim. One can maintain that A, relations require relata, that is, things which stand in the relations, but that B, these things do not have any intrinsic properties that underlie the relations in which they stand. There's nothing paradoxical in this latter claim. In this latter claim, this paper argues for no more than this claim. By a thing, I mean anything that is subject of a predication of properties, including relational properties. We call here relations, could be good to note. Without being itself predicated as a property of something, somewhere. I do not distinguish relations from relational properties. Relations are properties as well, albeit not monadic ones, in that they are predicated of things. Moreover, and it's getting complicated, something can be a thing without being an individual thing. For something to be an individual thing, further conditions may have to be met, such as A, being distinguishable from all other things by means of predication of some qualitative properties, or B, having a primitive thisness. Alternatively, hexity. 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 Let's go to the city where the Hexity. A metaphysics of relations can grant that things may have non-qualitative properties over and above the relational ones, such as the property of being this thing. That is a primitive thisness. But this position does not have to, which is important, does not have to admit primitive thisness. So in parentheses, that is not a claim of the article. End of parenthesis. Accepting that relations require things which stand in the relations does not commit one to the view that these things have a primitive thisness. A thisness. A thisness. It simply means taking into account that properties, including relations, are predicated of something. This does not imply that there is more to the related things than standing in the relations. if one does not endorse primitive thisness, one may say that the thing is a bundle of properties or tropes. How a thing can be a bundle of relational properties is no more and no less a problem than how it can be a bundle of intrinsic properties or intrinsic tropes. Intrinsic tropes.
Tropes.
Hence, both the view of things as being characterized by primitive thisness and the view of things as bundles of properties or tropes are compatible with the metaphysics of relations. Relations all over the place. Relations. The plan of the paper is as follows. Starting from a conceptualization of quantum entanglement in terms of non-supervenient relations. The next section argues for conceiving quantum entanglement as a case of non-separability. That is a case of holism. Holism. It is shown how this interpretation of quantum entanglement leads to a metaphysics of relations. Metaphysics of relations. The third section then establishes that this is a moderate metaphysics of relations in contrast to a radical one. In contrast to a radical one.
Radical.
Radical one. Radical one. Finally, this interpretation of quantum entanglement is put into a broader framework set out in this introduction. It is argued that this interpretation avoids a gap between epistemology and metaphysics. Whereas a metaphysics of intrinsic properties invites such a gap.
Gap.
A gap, a prominent gap. From quantum entanglement to relations without underlying intrinsic properties. Quantum entanglement. Quantum theory permits that the states of quantum systems are entangled. Instead of speaking of entangled states, one can also talk directly in terms of entangled systems. Entangled systems. Systems like a web. Like a spider's web. Like a complicated weave. A weave. A weave. However, since entanglement is state dependent, it seems more appropriate to use the notion of entangled states. Entanglement is to say that the quantum systems in question do not have some state-dependent properties, each independently of one another. And now we come to some pretty pertinent examples here. Position. Examples are position and momentum, as well as spin angular momentum in any direction. This is incredibly important. Instead, there are only correlations between the state-dependent properties of the quantum systems in question, encoded in a joint probability of distribution determined by the joint state. Quantum theory does not include any properties of each quantum system taken separately that are a supervenience basis for these correlated probability distributions. These correlated probability distributions. Furthermore, these correlations and thus entanglement are independent of spatiotemporal distance. the cause of entanglement. Quantum physics seems to exhibit some sort of holism. This way of receiving quantum theory commits us to realism. There are quantum systems and there are quantum theory. They are as quantum theory, describes them, namely subject to entanglement. Furthermore, we are committed to endorsing objective probabilities. That is, probabilities which do not simply indicate limits of our knowledge, but which are properties that things objectively have. Whatever entanglement may exactly be, it is a relation among quantum systems. Being entangled with is a property that is predicated of at least two quantum systems. It is thus a relational property. A relational property. Do you get it? Very important. As well worth repeating. I just repeat some it. Furthermore, we are committed to endorsing objective probabilities. That is, probabilities which do not simply indicate limits of our knowledge, but which are properties that things objectively have. And listen now, whatever entanglement may exactly be, it is a relation among quantum systems. Being entangled with is a property that is predicated of at least two quantum systems. It is thus a relational property. And do not fear, I will come back to this soon. By admitting entanglement, we are not committed to taking a particular stance on the notorious measurement problem in quantum theory. In quantum theory! Even if one maintains that measurement leads to a dissolution of entanglement, so that as a result of measurement, quantum systems really have definitive numerical values of the state-dependent properties in question. Each entanglement has to be there in the first place before it makes sense to consider the question whether or not there are processes that dissolve entanglement. It is not necessary that the states of quantum systems are entangled. Quantum theory has the means at its disposal to describe states of physical systems which are not entangled, that is, product states. However, quantum theory describes physical systems in such a way that entanglement is not at all exceptional, but ubiquitous. What has to be accounted for in quantum theory is not entanglement, but cases of the absence of entanglement. If there really are such cases, if not, it has to be explained why there appear to be such cases. Nonetheless, even if the states of quantum systems are entangled, it is possible to give a description of each of the systems in question considered in isolation from the other systems. This is a description in terms of what is known as a mixed state, in the sense of an improper mixture. Improper mixture.
Mixer. Yummy.
Mixture. Mix it up. Mix it up and see what happens. This description contains all the information that can be acquired about each of the quantum systems considered on its own. But it ignores the correlations in which the entanglement consists. Consequently, this description does not take all the factors into account that are relevant to the quantum probabilities. The description in terms of improper mixtures, therefore, is an incomplete description of quantum systems in entangled states. Entangled states. It is not a description that refers to intrinsic properties of each quantum system. And there, I think I will put a pause. It's perfect. It was a sort of
The ending of page 604.
Yes, and in the PDF, if you printed that out, it's 4. Last word being system.
Indeed, I show it 604. You see the number here, 604.
Excellent. So do be patient. This was incredibly complicated. Do also remember that when the 3 Nobel Prize laureates came up to Stockholm last year, the description of what they did to deserve such a fantastic prize was actually wrong. Even the professors at Swedish universities had not fully understood quantum relations. It's a tough nut to crack. I think part of their description was that Misters Aspect, Clauser, and Salinger deny that reality exists. What they deny is local reality. That would be, in this paper compared a bit brusquely, that would be that they deny intrinsic properties. But they are not anti-realists for any. Reality, according to Misters Salinger, Aspect, and Clauser, is global, which is a sort of holism in this paper. So what we now, with all this complication, went into is to show how even intrinsic properties could be coming from the system. Although there is a caveat here for a possibility of some sort of thisness, but not of importance. So we have, with the exception of that, we have mainly the Leibnizian system, I'd say. So all its relations, and remember also what the author Michael Esfeld mentioned about the spatiotemporal positions. And I think most people don't think about that. But being a point in the orthogonal perpendicular XYZ system, let's imagine you have 2 points, A and B. Maybe I should make that even clearer with a whiteboard. Let's see if I can get one here. Get a whiteboard. So as you say, we don't normally think about that. I'm going to make only two axes. That's enough. So if you have one thing here and one here, so even if they don't have any intrinsic properties, it would still be a sort of intrinsic properties, they being on this and this. So a position in the spatiotemporal web is also a sort of intrinsic properties. We don't have this in quantum mechanics, all this relation. We do allow for time and space, but so to speak, afterwards. So you also see here, I'm not pointing with my hand here, you can also see here that this makes possible to place everything and give them a sort of property of something being here and the other one being there. This is strictly not okay. This is not how it works. And now I think you also understand why Newton needed this spatiotemporal web to give everything their own individual character. Oh, that one is situated there, that one is situated there. This is, of course, denied by the uncertainty principle by Werner Heisenberg and many more, of course. I'll go to the first page, page number 1. The third line, the second line in the introduction here, this second paragraph under the subtitle Introduction 1. The framework is the one of a metaphysics of relations, in contrast to metaphysics of individual things that are characterized by intrinsic properties. This you should remember. This is important. This will help you to understand. And it sort of sums it up also, although in the expanded format, it's much easier to understand. And he's also a pointer, and metaphysics of relations is a minority view in contemporary philosophy. I say in contemporary language, in the argot of common people, individuality or intrinsic properties are assumed unthinkingly. So it's pretty massive. Do you understand that? It's pretty massive, the resistance. So we can go further to the next page, page 2, second paragraph. So this paper argues that quantum physics can be taken to suggest replacing a metaphysics of intrinsic properties with a metaphysics of relations. And I need to help out here in a parenthesis. That means that even the property of being absolutely individual, being a private thing, is also a property of the global take, of the relation of all. So it doesn't mean that there are no individuals, to further complicate the understanding, but individuality itself is stemming from all. Something that's been proven experimentally, which is very important, experimentally in quantum mechanics. Very important. So we go on the same paragraph there. We have a couple of summing up things that could be good. Don't press yourself to understand them already, but they could be helpful further in the paper as we go along. And metaphysics of relations is often dismissed out of hand, for it seems to be paradoxical. It seems that A, relations require relata, that is, things which stand in the relations. That is very troublesome, very important. If you have relations, you need something that stands in relations, and already you have thisness. So, very smart move here is to accept some sort of thisness, at least in order to get some understanding. It would be very hard to understand if if you don't start out with that. You can get rid of it later, maybe. Maybe you don't have to. But some sort of thisness will help the understanding. You will be able to put it into perspective. And I think that is only fair, because you were asked to be given up the spatiotemporal web that you've grown up with, which is deeply encasted in your language, which you've been using, I'd say, way before you even were born, or at least when you were born. Well, maybe you got it in the belly. This is deeply ingrained, and we should also remember Newtonian thinking changed Western language profoundly. Huge tendency started in the mid-18th century to make nouns out of verbs, to make movement into stillness, and so on and so on. So it's deeply ingrained. Let's go to the third paragraph. Towards the end, we have two more listed things. I'll just read them. An individual, further conditions may have to be met, such as A, being distinguishable from all other things by means of the predication of some qualitative properties. Remember, those are stemming from the wholeness. Or B, having a primitive thisness. And here you have this primitive thisness. I think you should let that be for a while. Let that be something. Let's assume that. That will help. It helped me reading this paper. Admitting that, we go to the next page, and we will go to the second paragraph. And on the second line, the next section argues for conceiving quantum entanglement as a case of non-separability. That is a case of holism. A lot can be said about that. So in relation to quantum mechanics, you don't have to postulate a holism, because think of it as this: if you don't have an individuality, you automatically have a holism. You see? That, in contrast to claiming a holism, in contradistinction to fragmentization. If the fragmentization is gone, you do not need to claim holism as strongly. Everything is a whole, has always been a whole, and in a way doesn't have to be defended that firmly as a whole, because it's always been a whole. Or even the property of being an individual. So let's go to the second subchapter, Quantum Entanglement. And here we have entanglement, and you can, at least in the beginning here, equalize that to a sort of a relation of the whole system. And on the fifth line here, you can see examples are position, momentum, as well as spin angular momentum in any direction. So even these things, as proven by quantum mechanics, are deeply connected to everything else. And I think maybe the most shocking thing here is spin angular momentum in any direction, at even that thing. I think I just remembered a thing here. Maybe you, if you want to have some visual object for this thisness, which I propose to keep in mind, you can use chirality. That's a thing that is very hard to sort of claim to be a relation. Of course, it is a relation at bottom, but it's very hard. So that could help you say, at least that thing could help us start with some sort of primitive thisness, and that can help you understand how things can be related. Later on, you can soften up, so you can widen your understanding to say that everything is entanglement. It needs to be done in a two-step procedure. Otherwise, it's too much to ask for any consciousness. And at the end of that paragraph, furthermore, these correlations and thus entanglement are independent of spatiotemporal distance. As I said before, that comes later. The XYZ system of the orthogonal perpendicular Cartesian Newtonian worldview comes later. Because of entanglement, quantum physics seems to exhibit some sort of holism. Well, definitely. Later on in the third paragraph here, on the sixth line, being entangled with is a property that is predicated of at least two quantum systems. It is thus a relational property. You need two to tango, so to speak. To put two things together or make two things happen somewhere, and then you will have an entanglement. And after that instance, which is called the event in quantum mechanics, then you are at liberty to put that in space and time, but only afterwards. Which makes the spatiotemporal web dependent on something that is more fundamental, if you like. The event is the sine qua non for any sort of spatiotemporal relation, not the other way around. This could be helpful because that is a pretty darn big difference compared to the Newtonian Cartesian thinking. I think I transgressed my time a bit here. Kalle, please join.
Okay, thank you. I hope you hear me well.
Very well. It's
Thank
extraordinary.
you.
Well.
Let me go to page 603. 603. There was this one phrase. Let me read it. I do not distinguish relations from relational properties. Relations are properties as well, albeit not monadic ones, in that they are predicated of things. Let us try to see how this Esfeld's theory in relation to the monadic theory. Let me show you, stop share, and I will now share the Wikipedia page on monads. I think it's useful. In monads, so monad comes from the Greek word for unity. Monas, unity, and monos, alone. And Pythagoreans use this circle with a dot to show that there is actually a unity. That is, there is a substance in all things. So this black dot, according to Pythagoreans, is a proof or indication that there is a substance to everything. Likewise, in this, I would say Pythagoreans have something in common with atomists, or today's atomist physicians. Atomists think that there is a basic property to everything. There is a thingness, there is something at the core. You have a core.
Something at the core, on the inside, yeah.
So did I summarize monads? But I don't know Leibniz how he would have said about if he would have agreed. I don't know if he Leibniz assumed that there is actually this substance.
Well, I think it could be a substance, but at least they have maybe some sort of thisness, but they do not have windows as I think the Pythagoreans and Aristotle would claim that they have some sort of thisness in the sense of an internal property. So you open the window, inside you find, oh, it's this very monad, not the other one.
While Leibniz would say that, what would Leibniz say instead?
It would say that they don't have windows and they have maybe, I think it's a good start to think that they have some sort of thisness to them. And we do not further define what this thisness could be. Because in that case, at least we can have two things. Maybe I should put myself in the picture here. Then we can have two things to have a relation with. Otherwise, it's very, very hard to start understanding these things. This is what I felt.
So we could imagine Leibniz's position as two circles of windows, so to say, and they can have sense only in relation to each other.
Yeah, sure. Yeah, why not? Yeah. I like
Although Leibniz said that there are not windows.
No.
They are, say, to say, like this one. You cannot actually see, it's not a window. It is, you cannot see through it. It's like two white balls.
Yeah.
But I don't know Leibniz if he assumed there is some intrinsic property to everything. Perhaps not, but I don't know if it's so important. But he said what is important for Leibniz is that is about relations. You need actually two white balls.
Yeah, it starts with that. And then you also have entanglement, which is also in that ballpark.
Okay, good. I will now return to that quotation by Esfeld. Let me see. Paper here. Let me see. So let me see here now. So he said, I repeat, I do not distinguish relations from relation properties. Relations are properties as well, albeit not monary ones, in that they are predicated of things. So it depends how monadic, if Esfeld means it in that in Leibniz sense or in Pythagorean sense. So perhaps it's not so important since Esfeld doesn't actually specify. Or how would you understand Hans's sentence?
I'd say it's not that important, and if you allow yourself what the thisness or hexity, I like that word. If you have some sort of primitive thisness, that's okay, and it will going to be very helpful for your understanding, because if you don't have a thisness, how can you then have a relation? It's very hard to understand that. You have nothing whatsoever in your mind to put your understanding on. So start out with that way, and I think that could be very helpful.
Let me
at least how I understood it.
Let me now. I think that Esfeld he's trying to, so to say, to have both the cake and eat it. When he says in that they predicate things, so Esfeld assumes that there is a thingness. While if I would be more radical than Esfeld, I would say everything depends. And Carl Rovelio, I think he would also agree with it, that everything depends on relations.
Yeah, that position is absolutely okay. Absolutely okay.
Okay, let me say one last thing. My favorite paragraph, it's on page 604. It's the third paragraph here. No, how do you count them? at disposal. Yes, this one. This one, I think, is very helpful. Quantum theory has the means at its disposal to describe states of physical systems which are not entangled, that is, product states. However, quantum theory describes physical systems in such a way that entanglement is not at all exceptional, but ubiquitous. What has to be uncounted for in quantum theory is not entanglement, but cases of the absence of entanglement, if there are such cases. So this actually, why is this helpful, this paragraph? Because it now materialists has to defend their position, because the materialist position actually the exception.
Yeah, indeed. I also like that one.
So this is this paragraph, I think, is almost genial.
Yeah, it is. It is. It should be cut in stone.
Yes, absolutely, absolutely. So I repeat the important sentence. Quantum theory describes physical systems in such a way that entanglement is not at all exceptional but ubiquitous. What has to be accounted for in quantum theory is not entanglement, but cases of the absence of entanglement.
Yeah.
If there really are such cases.
Yeah.
But now let me give the word to Mirja if she wants to say something.
Could I just add a little thing here?
Yes, please.
This is also the view of Mr. Aspect, Zeilinger, and Clauser. So that they don't see any exceptions to the idea that everything is entanglement.
Absolutely.
Sorry. Okay, go ahead, Mirja. Come in, Mirja.
It would be, it would be nice if we, could dwell a little bit more into this aestheti, because I know it from, let's say, it's a medieval scholastic concept. And then there is this aestheti as developed in Anglophone philosophy. And then later, the most important contribution with the continental, Gilles Deleuze and Guattari, and the intrinsic property, where the differences of substance, right? And that also referring to the relations. So, and then further on from the aestheti, once distinguishing the different concepts of different philosophical approaches to it, and then contraposting with what is aestheti only as in quantum physics, then it would be the next for me would be then what is the memory of the aestheti? Like whether then, I mean, if Hans could already say something, it would be great.
So what a good thing to say. Thank you, Mirja. What is the memory of aestheti? And thank you for giving the correct pronunciation. I said haxity. There must be some memory. Fine. Yeah, it must be some memory in haxity. It's very interesting, yeah. So thisness has some sort of connection to present and past, because memory is in the past. Very interesting. Very interesting. There must be some sort of feature there, I'd say, because we have a past in the universe as well. Well, thanks for that. That's all I can say.
Okay.
And I've been looking into, a couple of months ago, I started again with Gilles Deleuze and Guattari. Excellent scholars, I'd say, as well. I do like that philosophy.
Well, I propose that we leave it here. Perhaps we can have a chat after this recording, but let's end this recording here.
Sounds good. Okay.
I could only show before we end the homepage of this professor Esfeld. Let me see if I can get it.
Mr. Esfeld.
Yes, Professor Esfeld. I have his publications here. Then perhaps you can leave it there. This is he has publications in German, as you see, and that is about Wissenschaft, that is science, Rechtsordnung, science, and So he is very broad public outreach, science, freedom, and the rule of law. So he's fiat money, like postmodernism.
Very interesting. Got some podcasts there as well, and not too bad. Well, we end there, and I think that's his CV as well. Yeah. Very interesting. Well, thank you everyone for participating. Thank you everyone for listening in. Have an excellent morning, day or morning or afternoon, wherever you are. Bye-bye for now.